asking questions and then looking at data to explore those questions. Question: we know that the science you do is driven by the big questions around Earth system science. Could you please describe how you shape the questions that you ask before, during, and after you have collected data? How do you initially look at these data to help explore your initial set of questions?
The questions that I ask are shaped by the state of scientific knowledge on a topic, the availability of data, and their relevance to society, and my personal interest. I look for questions that have societal implications. For instance, our climate is changing, and we need to understand how and why Earth is changing so that we can help society make more informed decisions. Accurate predictions of the likelihood for potential weather and climate hazards enables us to move people out of harm's way and protect property. There are many societally relevant questions about the rapid changes in Earth's polar regions, and in particular the Arctic. The Arctic is a unique region of our planet, covered by large swaths of ice and snow for much of the year, and it's changing more rapidly than any other place. The characteristics of Arctic ice affect global sea level and ocean currents. We are all connected to the Arctic. What happens in the Arctic doesn't stay in the Arctic. I find the uniqueness of the Arctic very interesting, and in particular, the complex interactions between ice and snow, the atmosphere, ocean, and plants and animals. Next, when I look for a new scientific question, I like to read papers that describe scientific studies that compare model predictions to observations. When we compare model predictions and observations, we look at graphs that show predictions of the change in time of a specific variable, like the change in sea ice cover over time. We also look at spatial and geographic distributions of a variable like surface temperature, and you can look at these at the same time. Overall, the studies that compare model predictions with observations provide an indication of our scientific knowledge on a topic. When models disagree with observations, this indicates that a topic is not very well understood. All this information informs our understanding of a particular science topic and shapes the questions that I ask. Once I have a question, I look at the data that helps me to address this question, and I often start with the same data from the scientific studies that I initially read. When I first look at the data, I start by computing average values, and I look at the general characteristics of the data, like how does it vary in time? Does it have a seasonal cycle? When looking at the relationships between two variables, I compute the statistical correlation in time and in space. This provides valuable information. As I start to look further into the data, my questions evolve. I find that I almost never answer the question that I set out to answer, because oftentimes the data isn't available. When analyzing data, I am always surprised by what I find. The data often tell a more complex and intricate story than I thought in my initial hypothesis. I always keep an open mind. When I find surprising things in the data, I like to explore those new ideas. So during my studies, my questions and hypotheses morph into something different. Not a completely new question, but a different question that's related to my initial one. Analyzing data always leads to new ideas and uncovers new questions. Exploring and formulating science questions is really a continuous process. We're always finding new questions. It's like a circle of science, where the last question that you ask often influences the questions that you ask in your next study. It seems we're always uncovering more questions than we can solve.